Ma'am?
Ma'am, who's that? Shane, tell me, ma'am.
Ma'am, the last session you told that you'll deal with my question.
Which question, dear? Can you please repeat it?
Sure, ma'am. Why is water called liquid?
Because of the arrangement of
Particles.
The state of the matter, any state of the matter, any matter. Not only don't call them as water, don't call your substance as water. But we call them water is based on the molecular formula, that is nomenclature, that is secondary. Okay. So why we call the water in the form of liquid only? Because of the arrangement of particles. I think this I have told you. I said that in the coming session I am going to discuss your question.
Yes, ma'am.
Yes?
Ma'am, I
Yes.
also have a doubt. Why are the
Yes,
molecules in liquid arranged, not arranged like solids? Why are they arranged so loosely?
Because it's own property, because it's fluidity in nature. It's fluidity in nature. When I want to throw this duster, I just throw the duster so that at one particular place it just placed over there. When I do same thing with the water, is that the water will stick to that particular place based on my force. The water is fluidity in nature. It floats because of the arrangement of particles. And this is the question, like I remember, like previous 6 years back question in standard 9. That time it was like a board examination for standard 9 also. There they have asked why O2 and N2 are in the form of gas. 2-mark question. But simply what you'll think, because they are in the gaseous form or gases, they are like that. But the main answer is based on the intermolecular forces, based on the structure of molecules present in it. The same oxygen, the same liquid can exist in different states. Yes? Understood or not?
Yes,
Let me give you more clarity for your doubt. Okay, you said that why water is in liquid state. Am I right here? Yes, ma'am?
Yes, ma'am.
Yes. So the same water can exist in 3 states: solid, liquid, other one is
Gas.
gas.
Yes.
Yes? Yes. So when it is solid, what happened? The particles, like the original water molecule, you can see in the screen, the arrangement of water molecules or any other liquid molecules are like this. Yes?
Yes, ma'am.
So when I want to convert the liquid into gas, so what I do, I apply some pressure or difference in temperature, the particles will come closer. If I apply pressure on the liquid, they'll come closer. When you want to freeze the water in refrigerator, what you'll do, you just give some difference in the pressure and the temperature. Yes? Yes, ma'am. Difference in the pressure and temperature. Then what happens? The particles will come closer. Then the same water converts to
solid.
Understood here?
Yes, ma'am, I got it.
Very good. And here, normally the water is in at like normal room temperature, the water is in the form of liquid. Okay. So gas. When I apply temperature, when I change the difference in temperature and pressure, again, if the particles are like this on the screen which they represent, so when I give the change in temperature and pressure, the particles will go far from each other.
Yes, ma'am. They turn into gas.
Yes. Now you understood, dear? Yeah?
Yes, ma'am.
Very good.
Thank you, ma'am.
This is your doubt. That's why I asked. It's not a silly question. You have asked a very good question. I said this?
Yes, ma'am. You told it.
Very good. Very good. Good interaction. Okay. Yes. Next. Gases. Next state is nothing but gases. A gas is a state of matter which has definite mass but no definite shape and volume. We know that. We can't hold, like if I want to hold the gas, is the gas will stay in my hand like this. Easily, the gas can easily expels out from my hand from a small gas present over here. Yes, here? Yes, children?
Yes,
Yes?
ma'am.
Why?
Yes, ma'am.
Because gas is also fluidity in nature. Gas is also having fluidity in nature. That's why it can easily move. It can easily move. It doesn't have a definite shape and volume. No direction at all. At least water can attain the shape of the container. But gas, it doesn't have any direction. Randomly they'll move. Because they are having more kinetic energy. The force of attraction, there is no chance. They'll go, this, like, have you seen the nursery children in the classroom? They'll sit in particular classroom, particular place? No. They'll see the teacher, they'll observe the teacher, mom, and they just go here and there. There is no direction. Yes? So we need to mold it by some instructions or something else. The same way, these gaseous particles also, there is no direction. Okay, canopy I said, na? Continuous moving of particles, canopy I said. So that's why we can see the dust particles, how they are moving in zigzag manner. Based on that dust particles, then only we can know that like this, the gaseous particles are moving. There is no evidence of gaseous particles, like visible evidence is not there. We can see the gas here, I can see the gas moving over here. I can say the direction. No, I can't determine the direction of the gas.
Ma'am, if we
Understood?
take bromine vapors, then we can study the movement of gases.
That's why I said it's an evidence. It's an evidence. We won't see the gaseous particles. Okay, we won't see the
Ma'am,
gas
bromine
particles.
vapors are brown in color, so when
brown
they are
in
kept
color.
in test tube. So.
Okay, they released in the, it's like non-metal bromine gas. When it releases, we can see the colored gas. It depends upon texture. That is also physical property, child. But in general, when we say, when we prove the evidence, simply if it's a color change, no need of evidence for the bromine gas. Yes? Yes or no? Because
Yes,
by the simple color, we can say the fumes. Yes, with the fumes, we can simply say that they are moving. But for what about the colorless gases, oxygen, nitrogen, hydrogen, carbon dioxide, are these gases are visible? Or they release any odor? Yes?
Yes,
We are
ma'am,
having
odor.
any odor of oxygen? Bromine gas fumes, we can see we can't bear the fumes. Okay, our eyes get burned. Like burning sensation, itching sensation we feel. We can't inhale that gas. But in case of oxygen, nitrogen, hydrogen and carbon dioxide, they'll do evidences for these kind of gases, children. Okay. Anyway, we are not discussing about the chemical properties. We are going with the physical properties. I said before. Yes? No, very good about the bromine gas, fumes of the bromine gas. Okay, here high compressible, they are very highly compressible because the gaps between the molecules are very high. So we can make it compressible. Okay, density is very low. I said no, less amount of gaseous molecules also occupies more quantity. Okay, more space. So the density is very low when compared to solids and liquids. Next, intermolecular forces are negligible. I said no, there is no direction. One molecule can't say that you be with me only. No, we can't say because they are negligible. They are like strangers. They are like strangers. Okay, if any stranger is going or just passing through, what we just call the stranger and will talk. No, we won't do that. Yes or no? Because there is no intermolecular force is negligible. Expands highly on heating. Expands highly on heating. Gas particles itself having the kinetic energy, when you give the temperature to it, what happened? It attains more kinetic energy and the movement will be very fast. That's why LPG cylinders, we won't give temperature, like external temperature, we make it cylinders to be at a room temperature. Yes or no? So when we give the temperature, what happens? The particles in the LPG cylinder, they increase the kinetic energy, they strike the walls of the container and the pressure changes. Immediately there is a chance of explosion. Understood, children? Diffusion is homogeneous. Diffusion is homogeneous, means they mix up with the gaseous particles completely. Okay? So the separation of gaseous particles, again there is a particular or specific separation technique to separate the individual gaseous or gas particles present in the air. So the diffusion is homogeneous. Homogeneous means uniformly they'll mix up. Uniformly. Understood or not? That's why there is a release in gas in the kitchen immediately with the help of order. How the immediate order will come, children? Because the gas released from the cylinder will mix up. Diffusion takes place there. They'll mix up with the gas particles present in the atmosphere. So they travel from one room to the other room, so that immediately we can't see the release of gas. No? We can see the release of gas from the cylinder. We can't see. Even sometimes there is no release of sound from the cylinder. If we go near to it, if we are at distance, a far distance from the cylinder, from the kitchen, how can you know that there is a release of gas from the cylinder? The help of order. This is because of diffusion. Diffusion is homogeneous. Yes. Anna?
LPG is an odorless gas, so odor is added
No.
to LPG gas.
LPG is not an odorless gas, it's an order gas. It's a combination of butane and propane. It's an ordered gas. Like methane, we used to use methane first. It's an odorless gas, so there is a chance of explosion. So then only they consider LPG as a domestic gas.
Ma'am, LPG is odorless and ethyl mercaptan is added to it so that
that's why here they consider the proportion of propane and butane. Again, they maintain the ratio, that is propane and butane. Understood, Anna?
So, ma'am, do they have odor or do not?
No, LPG is having odor. It's a simple, this practical thing. If there is a release in the LPG cylinder, we can feel the odor, na?
Ma'am, I mean only the LPG gas. Only LPG, no any other gas added to odor.
The LPG itself is a combination of butane and propane, Arnav. LPG itself is a combination of butane and propane. Understood? But I'm not saying that it's a perfect composition, but the main components of LPG is butane and propane. This you'll study in standard 10. Any more doubts? Okay, shall we go towards the topic? Yes? Yes? Here, highly compressible, our density is very low, intermolecular forces is negligible, expands highly on heating, diffusion is homogeneous. These are the properties of gases. Understood, children? Next, we see that just the comparison by seeing the structures of solids, liquids, and gases. So solids are very compactly placed, liquids are having less force of attraction from the solids, and gases are having more force of attraction. Gases are very less force of attraction between each other. Have you seen the comparison of solids, liquids, and gases? How they have arranged? Understood? So we have discussed about the shape, volume, compressibility, density, arrangement of the particles, diffusion, surface. What do you mean by surface, children? Solids have any number of surfaces. Solids have like three-dimensional structures we can say about the solids. Am I right? Okay. For the three-dimensional, like different surface sides we can see for the solids. In case of liquids, only one upper surface. Only one upper surface. If it is a transparent container, we can see all the sides of the liquids. But in general, when we consider liquid, we see on the one side, that is top surface of the liquid. They have no surface. For solids, they have no surface. This is about the surface comparison of solids, liquids and gases. Kinetic energy. Kinetic energy. Kinetic energy. Solids exhibits least kinetic energy. Liquids slower when compared to gas. Gases are having high kinetic energy. Yes or no? This also we have discussed. Rigidity and fluidity. Rigidity comes solids comes under rigidity or fluidity. I know you have sent me that research result, that snippet from the web. Propane and butane gas are odorless just like natural gases. Natural gas, in order to detect any leaks or strong bad smelling substance. Yes, what I said is correct, what you have asked is correct. But LPG is an odor gas. Before they used methane, you can search methane. Methane is odorless gas. So whenever the scientists do the things, and methane is more expensive than propane and butane. Okay. So here LPG is a combination of propane and butane. So why they have added this proportion is in order to detect the smell. Okay. Understood or not?
Yes, ma'am.
This is nothing but yes, very good. There are so many reagents, but these are the best compositions of the LPG. Okay, this you learn in the hydrocarbons lesson. Then you can understand. We won't consider all the reagents. We consider the most high composition reagents. Yes or no? Then this comparison, so solids, liquids and gases. Fluidity, rigidity, solids are considered as rigid, whereas liquids and gases considered as fluids because of the intermolecular force of attraction. Next, motion of the particles, like movement of the particles. Movement of the particles.
Least in solids, moderate in liquids, and maximum in gases.
Definitely. Based on the, that's what I said that if I give the external force only, this duster will move from one place to the other place. Otherwise it won't move. But in the same way, in an open area, if I pour some amount of water, is that the water will be at the same place? No, it just spreads. Understood? Because of the fluidity nature. And gas always floats. It's having more freedom when compared to solids and liquids. Understood? Next. Interparticular attraction force. Solids are having more intermolecular force of attraction, whereas liquids and gases are having less. Like simply we can say that moderate in case of liquid, but least in case of